Renewable energies in their current form cannot meet the power demands of our modern age. To find the next generation of power production, we must look to the most powerful reactor in our knowledge, the sun. Fusion power can not only help us wean off our dependency on fossil fuels today, ultimately lowering our production of greenhouse gases, but achieve a sustainable level of operation to meet the power demands of tomorrow. On Earth, 59% of our global energy production is via means of burning oil and coal. This means of energy productions have been used for many years but have proven unsustainable for our rising needs. Given our current boom in population as well as the revolutions in our technological sector, the world becomes more power hungry with each passing day. By continuing to meet these energy quotas by non-renewable means, the effects of climate change are accelerating. By 2050, America's summers could be 5.6 degrees Celsius higher than they are today, resulting in massive ecological changes that we are just not ready to deal with. For this, many leading experts are pointing their gaze to the sun for the answer. Fusion energy promises a solution. But how does fusion work? How do we achieve fusion? Is it just as dangerous as traditional nuclear energy solutions? And when can fusion technology become a viable commercial option? Traditional nuclear power plants rely on fission reactions, the splitting of unstable atoms. Fusion is the combining of two smaller atoms into a larger atom. If the splitting of atoms like we know in our power plants releases energy, then how does combining atoms not require energy? Well, this is explained by looking at the atoms and Lego blocks, the nucleons. Strong nuclear force is responsible for binding the nucleons together, and the strength of the interactions can be quantified by the specific atom's binding energy. Whenever two atoms interact, there is a release in energy provided the products possess a higher binding energy than its reactants. Just as the fission products possess a higher binding energy than its reactants, as seen in uranium-235 fission, the same holds true for fusion and is seen in the graph above. The fusion reaction we find yields the most power and is the easiest to perform is pictured here. We see two isotopes of hydrogen, and by pushing them very close to each other, we can produce helium and energy. Notice none of the reactants are very harmful, so if there would ever be a spill or contamination of the reactants or the products, it would be no major safety concern. This is a major benefit over traditional nuclear technologies. The feat of pushing these two atoms together and effectively fusing them is done by magnetic confinement. That is, hydrogen isotopes are accelerated as a plasma, basically an electron gas, and combine with each other, releasing energy. We keep all of this plasma confined in a magnetic bottle. This design is called a tokamak. The world's most advanced tokamak is the International Thermonuclear Experimental Reactor, or ITER. So we have our solution. Why don't we implement fusion immediately then? As it stands, to run our special plasma donor requires more energy than it produces once fusion occurs. That is because materials used in the reactor are not yet advanced enough. This brings up the uncertain future of fusion. Experts don't know yet how much power we can realistically harness from the fusion process. Additionally, new designs and materials are required to push fusion to a commercial level. But this is already happening with many improved designs such as the Wendelstein reactor in Germany, giving us a better magnetic bottling. Fusion takes money, so we need to convince our industry leaders and politicians that the potential payoff of clean energy is too great to pass up. In summary, fusion is clean, fusion is powerful, fusion is sustainable, fusion is the answer. Investing in fusion today is investing in tomorrow.